All right, so in this video, we are going to prove the following. Right, what this is saying is that the divergence of a scalar field times a vector field, or in other words, this is just the divergence of a vector field, is equal to the gradient of u dotted with vector v plus u times the divergence of v. And so we're going to prove this. To start the proof, I will rewrite the left side of the equation right here. So, really we're taking the divergence of something. What I'm going to do is I'm going to re-express the del operator in terms of what it is. Right? And we're dotting it with uv. But since I've broken this up into components, I'm going to break this up into components as well. Just like that. And so really we're taking the divergence of this thing, which means we're basically doing partial derivative with respect to x plus partial derivative with respect to y plus partial derivative with respect to z. And that's all we're really going to be doing. Now here's the thing. When we take the derivative of each of these things, none of these things are necessarily constants. So really we're going to have to use the product rule for each of them. And so using the product rule for each of them, we get and so now we have done that. So notice in these terms that I'm underlining, these terms all contain u. We're going to group the non-underlined terms together. And we're going to group the underlined terms together. But notice that we could factor out a u from those underlined terms, so I'm going to factor out a u. And so this is what we have now. Now the thing to notice from here is that these first three terms is really a dot product. It's the dot product of the gradient of u with vector v. And for this portion, it's really just u times the divergence of v. And so now we have proven that the property holds. These two things are in fact equal to each other. And so this is basically the whole idea. So now we have proven this, and so this is basically it for this video.